Hello students, welcome to today's lecture on EV motor selection criteria. So choosing the right motor is very important in electric vehicle because it directly affects the efficiency, driving range, cost and overall user experience. So in this lecture we will be discussing about how to choose the right motor step by step using a structured approach. So let's first understand why motor selection is important. The motor decides how the vehicle accelerates, consumes energy, performs on roads. For example, a powerful motor gives better acceleration. An efficient motor gives longer range. So we need a proper method to select the best motor on user needs. So now we move on to the first step, how we convert user need into technical values. So the key parameters that needs to be considered are power, how strong the motor is, then torque requirement, which is the pulling capability, and then speed range, RPM, how fast it rotates, then efficiency, which deals with the energy usage, and the thermal limits and cooling methods, which gives about the heat handling capacity of the machines, and then packaging constraints, which is the size constraints, the space availability. For example, if the vehicle is for hills, we need high torque. Right? If the vehicle is for sports purpose, we need high power rating, right? So in this manner, these parameters needs to be considered while selecting a motor. The next step is we are going to explore the different motor options we have. So as we discussed in the previous video, we have different types of motors like brushless DC motors, BLDC, permanent magnet synchronous motors, PMSM, induction motors, and then switcher reluctance motors, axial flux motors, etc. So we can compare them based on cost, efficiency, complexity. For example, BLDC motors are so compact, but PMSM motors gives high power. Induction motors are simple in design and switchable reluctance motors are highly efficient. So think of it like choosing a mobile phone for your daily usage. We compare certain features before buying, right? So we have features and we have different motors. So we need to map them to give the better result. So now let's look at the main criteria for selecting a motors. The important factors include power to weight ratio, torque, which is peak versus continuous torques, and then efficiency in real driving conditions, thermal performance, reliability and durability, cost per kilowatt, and how easy the manufacturing is of these motors. So in simple words, we can say we want a motor that is powerful, efficient, durable, and also affordable. So once we select the motor based on these options available, we move to prototype stage. So here we don't directly build the motor, we first test it using simulations like drive cycle simulations, wherein which we pose real driving conditions and efficiency mapping, then thermal simulations like heat analysis, and also we will be testing controllers. So in order to make controller integration validations. So this helps us to avoid mistakes before the actual production. Then we will be testing these motors. We have different types of testings like bench testing using machines, on-road testings wherein which we will be analyzing the real performance of motors, and then heat and endurance test, and then noise and vibration test, harshness test, NVH test, in order to evaluate the design step by step. and then we will be iterating these steps again and again by making changes in the output. So it is like a feedback mechanism. In real engineering, we cannot get everything perfect, so we do trade-off analysis, wherein which high we may have a compromise between the factors like high efficiency versus high cost, and high performance versus battery range, and low weight versus high powers. So we choose the best balance based on the applications. Finally, we need to talk about the sustainability. Modern EV designs must consider use of rare earth materials, recyclability, because the batteries, it cannot be recycled once it is degraded, and then energy efficiency of the motors, and the life cycle cost analysis of this EV. So the goal here is to design a motor that are eco-friendly and future ready. So now let's summarize what we have discussed so far through this video. So we discussed about the motor selection. It is a multi-factor decision. We use a structured approach, like we defined what we need, then we ideated, then prototyped, and we tested it for a real-time proper selection for the application. So we balance performance, cost, and sustainability. So a good motor selection leads to better EV performance. So let's recap the contents we have discussed using this motor selection design thinking mind map. So we empathized what the user actually wants, then we defined the specifications which needs to be considered, then we ideated with the motor types, and finally we validated, and that is tested, and then we made the EV motor selection. Now here is the let's apply what we've learned. I have given a scenario wherein which we are going to design an EV for a hilly terrain which needs high torque of the range 180 kilometers, and it should be a budget sensitive for customer segment. It is for a budget sensitive customer segment. So the question here is, which motor would you select and why? We have the options like PMSM, BLDC, induction motor, and SRM. So think based on the factors we have discussed previously: efficiency, cost, torque, sustainability, everything. Okay, so based on this, we need, of course we can get 2 or 3 options, but stick on to the scenarios where we have to select the correct motors for the applications. So that's all for the today's today's lecture. So thank you for watching, and if you have any doubts, feel free to ask. See you in the next class.